So I had started with problem 3 on showing that if 2 to the n minus 1 is prime, then n is prime. And here is the proof written out. Just continuing that discussion. The converse isn't true. P can be prime, but 2 to the p minus 1 does not have to be prime. And in fact, it's a famous ancient problem in number theory, in algebra, to determine if in fact there are infinitely many primes p where 2 to the p minus 1 is prime. These are called Mersenne primes. And no one knows whether or not there are infinitely many of them. There's actually something which teachers often use in their classrooms. They download a computer program and they run their computer when it's not being used for anything else, looking for primes of this form. And every now and then one pops up and they get their name in the New York Times because they have found up until that instant the largest prime number known to the human race. So the very largest primes known are usually these Mersenne primes. But there still are very few that are known. Then I talked about the problem of showing that determining for what integers, positive integers n, n plus 2 and n plus 4 are all prime. And this is only true for n equals 3. And then the last thing was what I just did, the proof that if you take any two positive integers, their product is equal to the product of the greatest common divisor and the least common multiple.
More I'm missing.
Right. Are there any other questions?
The birthdays. You mean almost technically? You said Ethan was going to the park to hang out.
Did we are
To go celebrate a birthday? It's not so. Oh my goodness.
Mute your.
I thought you organized it.
Don't organize anything. I said it to her. If she get her work done, then maybe we could go meet up with Lena and see what she's doing. Then she came back and said, Lena said she's going to Nice Good Park at 5.
Last question. One of the questions was to prove that using the infinity of the prime number was to prove that, all nth prime is going to be less than 2 to the power 2 to the power n. Is that would induction be the right approach for that?
Well, you never can say what is the right approach. You can say that that's a reasonable approach, and you can try that.
Okay.
And see if it works. If it works, great. If not, ask me on Monday, and I will try to figure it out myself.
Okay, no problem. I mean, I already tried that and submitted that on the homework. I was just wondering because that 2 to the power 2 to the power n seems like an enormously large upper limit.
Yeah, it's large. If you can make it smaller, that's good. I mean, the truth is that the nth prime is approximately n times the natural log of n. But that's more complicated to prove. Anything else for today?
No, that's all. Thank you.
Anybody else? Okay, then. Everybody have a good weekend. I will be recording more lectures over the weekend and posting them. If possible, I'll try and get a little bit ahead, but we'll see. In any case, that's it for today. For whoever is interested, I will talk to you on Monday at 11 o'clock.
Thank you.
All right, bye.
Thank you.